Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe, and share. Alright, so today we are going to deal with probability. So probability is simply a science of uncertainty. So in inferential statistics, we have uncertainties that occur there. So in this uncertainty or uncertainties, the probability helps us to determine the various uncertainties that happen in inferential statistics. So in order to understand probability, we have to be familiar with this formula that probability P is equal to the number of the number the number of a particular sample the number of a particular sample divided by the number of all samples. The number of all samples. So let's say that the particular sample we want to talk about is A, and let's assume that the number of all samples is S. So the formula for the probability becomes the number of sample A divided by the number of all samples. So this is the basic idea of probability. So in order to further understand these principles of probability, let's introduce the idea of the Venn diagram. All right, let's introduce the idea of the Venn diagram. The idea of Venn diagram. So this Venn diagram actually helps us to, is a graphical representation of events for clearer understanding of the probabilities. Okay, so the Venn diagram helps us to see the graphical representation of the probabilities, and of course makes the work clearer for us to see. So in order to understand the Venn diagram, there are basically some few items that you need to know. So the first one is what we call the union of a set. The union of a set. So the union of a set is actually written in this form. Let's say A is a particular set and let's say B is another set, okay? So the union of A and B is written like this: A union B. So this is pronounced as A union B, where this symbol here is called union. So A union B is simply the joining of all the sets in A and all the sets in B without repeating any number. Okay, so let's assume that A contains a particular set of 1, 2, 3, and 4. And let's say B contains a particular set of 3, 4, and 5, right? So, and you want to get A union B. So as I told you, A union B is simply the joining of these two sets without repeating any one, right? So without repeating any one, A union B here will now be equal to, without repeating any one, we have 1, 2, 3, 4, and 5. So this is A union B. So the next one we have to deal with is called the intersection of a set. So intersection of a set. Intersection of a set. So in intersection of a set, let's say A and B are the two sets that we want to intersect. So the symbol for intersection is written like this, okay? So this is the symbol of intersection. So A intersection B now means all the values that A have and B also have those values. So let's use this same example, right? So as I told you earlier, the intersection is all the values of A that are also in B. So what values of A that are also in B from the first example? As you can see now, A intersection B is, both of them have 3 and 4. So the A intersection B is 3, and 4. So that is the answer for in the intersection. So the next one you have to know is what we call the universal set, right? The universal set. So the universal set actually is the set that contains all the functions that we need. So let's take for example all numbers ranging from 1 to 10. Let's say the union of all numbers from 1 to 10. All numbers from 1 to 10. So this is an example of a universal set. It's a set that contains all the numbers from a particular set that you need to know. So that's what we mean by universal set. Now the next that we need to know, the last but not the least that we'll discuss for now on this video, is called the complement of a set. Complement of a set. The complement of a set. So the complement of a set is simply all that is in the universal set but not in a particular set. Are you there? So let's use an example. First of all, the complement of a set is written as, let's say you want to find that of A, will be A prime. Either you call it A prime or you call it A complement. So A prime or A complement is what are in the universal set but not in A. So let's use this first example that says 1, 2, 3, and 4 is actually A. And of course, the universal set is all numbers from 1 to 10. So A complements will not be all numbers that are not that are in the universal set but not in A. So what are the numbers? So we have 1, 2, 3, and 4 are that are in A. That means 5, 6, 7, 8, 9, and 10 are not in the universal. Are not in A. So this is the complement of the set. So do for B complement. You can pause the video and attempt the B complement. So the B complement is actually equal to what are in the universal set but not in B. So B only have 3, 4, and 5. It doesn't have 1, 2, 6, 7, 8, 9, and 10. So this is the universal set of this is the complement of B. So we are going to solve through an example and we'll see how we can utilize further these ideas, right? So I have an example here. Of course, we are going to solve through 2 different examples. So but let's see the first one first. So the first one says that says the relationship that exists between A, B, and C is represented in the Venn diagram as shown. So you say from this diagram that we have here, we should find A intersection B, B intersection C, A union C, B prime intersection A intersection B intersection C, and A union B intersection C prime. All right, so we are going to walk through this, but let me give you a general idea on how to read through the Venn diagram. So whenever you see intersects, as I told you, intersects is actually where the 2 letters are connected, right? Union is actually the joining of all the letters, and of course prime is the complement. As I told you, is pronounced as the complement of a set. Is actually what is in the entire box but not in a particular letter. Are you there? So drawing this diagram, this line, this box you see here, means that the universal set is all the letters in this box. Okay, anytime you see a Venn diagram and they drew a box like this, so the box means that every letter here is inside the universal set. All right, so with the few ideas that you know, so you can also pause the video and try the answers to this question. All right, so let's solve through the answers now. So solution. So for the A part of it, now, the A part of it says A intersection B. So let's go to A now, see A and then see B. So does A and B have in common? Now look at the circle of A, right? Look at the circle of B. So what do they have in common? As you can see, they have 1 and 2 in common. So A intersection B now, A intersection B is equals to 1 and 2. All right, so let's check the B part. The B part says B intersection C. So the B part now says B intersection C. So this is B now, right? And this is C. So what is in C and also in B? As you can see, we have 1 and 3. So 1 and 3 is in C and also in B. So we have 1 and 3. All right, so the next that we have to do here is A union C. Okay, A union C. So in doing A union C is simply the joining of all the numbers in A and all the numbers in B without repeating anyone, right? So when we try to join, let me write out the values of A. So A is actually equal to, look at the box of A. We have inside this box of A, we have 1, 2, 4, and 7, right? So we have 1, 2, 4, and 7 as the value of A. And the value of C, okay, so the one we are solving for is A union C, right? So the value of C, let's look at the box of C, or the circle of C rather. So we have, looking at this circle now, we have 1, 3, 4, 5. So we have, so C now is 1, 3, 4, and 5. So these are the values. So what you just do is to join them together without repeating anyone. So then the C part now, which is A union C, from what we've seen so far, A union C will be equal to what is in A and in B joining and in C when joined together. So we have 1, 2, 3, 1, 2, 3, we have 4, we have 5, and we have 7. So 1, 2, 3, 5, 1, 2, 3, 4, 5, and 7. So that is the answer to the C part. Now let's go to the D part. So the D part says B prime intersection A. B prime intersection A. So for you to understand the B prime, you have to know the B prime. So as I told you that this box represents the universal set, which means for us to understand that the D part of it, which is B prime intersection A. So let's know what the universal set is. So the universal set here is equal to all the numbers. So from here you can see that we have 1 to 7. We have all the numbers 1 to 7. So we have 1, 2, 3, 4, 5, 6, and 7. And then looking at B, you have, just look at B here, you have 1, 2, 3, 6. So B, you have 1, 2, 3, 6. So B prime now, B prime, which is B complement, will be what is in the universal set but not in B, right? So as you can see, 1, 1, 2, 2, 3, 3. So it doesn't have, what is in universal set that's not in B is 5. There's no 5 there, and there is no 7, right? There's no okay, there's no 4. There's no 4 there, there's no 5, and there's no 7. So that's the B prime. So now B prime intersection A is joining A and what A has, and B prime also have it. So judging from here now, A has 4 and 7. B prime also have 4 and 7. Hence the D part now, B intersection A will be equal to 4 and 7. All right, so for the E part now, that says A intersection B intersection C. So it means where all the circles connected together. So as you can see, if I take the C part now, I'm seeing 1 here. If I take the B part, I'm seeing 1. If I take the A, so 1 is the this one here is the number that connects A, B, and C. Hence, the E part now, the E part of the equation is, which is A intersection B intersection C is equals to 1. So that's the value of the answer. Now the last part of the equation, that says, A union B prime, A union B intersection C prime. So so what we have to do is to find A union B first. So A union B, okay, I've written out A before and I've written out B before. So let's get our A union B. So A union B now will be to join all the letters in A and all the letters in B without repeating anyone. So we have this my B and this my A. So we have 1, 2, 3, 4, 6, and 7. Okay, now C prime, let's get the value of C prime. So from here now, C prime is let's get the value of C first. Okay, we have C here. So C is 1, 3, 4, and 5. So and the universal set, as I told you, is 1, 2, 3, 4, 5, 6, and 7. So what's in the universal set but not in C will be our C prime. So C prime now will be equal to, so C doesn't have it has 1, but it doesn't have 2. So there's no 2. There is no okay, there's no 2. It only have 3, 4, 5. 1, 3, 4, 5. So there's no 2, 6, and 7. So there's no 2, 6, and 7. All right. So A union B intersection C prime now will be equal to what is in A union B, and it's also in C prime. As you can see, both of them have 2, 2, 6, 6, and 7, 7. So we have 2, 6, and 7. So this is how to solve the Venn diagram. This is the first example. So I hope this video was useful and helpful. Please remember to like, subscribe, and share. Thank you.